Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to give the good information to you. So, what is that? We are going to discuss about one more important question solution, that is quantum mechanics, equation of motion in quantum mechanics. What is the equation of motion in classical mechanics? We discussed in our previous videos. Once you have to check under the playlist of the core syllabus of the classical mechanics. Under the advanced syllabus of the classical mechanics also I told to you under the Poisson bracket. Now you have to see here in the CSIR examination June 2015 there was a question. What is that question? A particle of mass is m is in a potential V is equal to 1 by 2 m omega square x square they are giving. V is equal to 1 by 2 m omega square x square, where omega is the constant. They are giving one operator, that is a operator is lowering operator. This operator we also call it as a annihilation operator or destruction operator. So, what is that lowering operator? M omega is divided by 2 h cut into m omega is divided by 2 h cut into x cap plus ip is divided by m omega. They are giving this operator. Now, they need to ask the Heisenberg picture. dA by dt is equal to how much they are asking. How we have to solve this question? We are solving based on the equation of motion under the quantum mechanics. First we have to see how we have to solve the equation of motion under the quantum mechanics. We know that equation of motion in what? In quantum mechanics. Equation of motion in quantum mechanics we need to calculate. What is that? The rate of change of operator, the rate of change of expectation value of lowering operator is equal to 1 by I h cut into 1 by I h cut into expectation value of this operator commutator of operator comma h. So, plus the average value of dA by dt. This is the expression. This what expression it is? This is the equation of motion of a quantum mechanics, equation of motion under the quantum mechanics. Clear? So, what we have to write here? So, we need to take dA cap is divided by dt is equal to 1 by I h cut into the expectation value of a comma h. So, a comma h. So, plus we need to know a does not dependent on time. A does not depend on time. So, that is why dA by dt is equal to 0. If a does not dependent on time, so that is why we have to take it as a dA by dt is equal to 0. That term is going to take it as a 0. Now, we need to calculate first commutator a comma h we have to calculate. So, what is the Hamiltonian? That Hamiltonian is equal to, this is a kinetic energy operator. So, the kinetic energy plus potential energy. Already potential energy they are giving. Kinetic energy is equal to p square by 2m. Potential energy is equal to 1 by 2 m omega square into x square. This is the h cap you have to write it is. So, therefore, what we have to write? That a you able to know. A is equal to already is there. That operator is square root of m omega is divided by 2 h cut. A is equal to, what is that operator? Once you have to see the operator m omega by 2 h cut into x cap plus ipx. Which one we have to write it is? X cap plus ipx is divided by m omega. This is the a value. comma h is equal to p square by 2m plus 1 by 2 into m omega square x square. This is the value you have to see. By using the linearity property, which property you have to use? By using the linearity property, are we able to attempt, once you have to see commutator a comma h is equal to, commutator a comma h is equal to, what is the constant term? That constant term you have to take outside. M omega is divided by 2h cut, you have to take outside. So the inside, so what are the terms are there? In the first a operator, x plus I px by m omega is there. X plus I px is divided by m omega. So x plus I px is divided by m omega. What is the Hamiltonian? Px square plus px square is divided by 2m plus 1 by 2 into m omega square into x square we are going to get. So this is the commutator. Now you have to take square root of m omega is divided by 2h cut into. So now you have to apply the linearity property. Which property you have to apply? A linearity property you have to apply. By using the linearity property, are we able to write the linearity property? This x commutator x comma px square is divided by 2m, commutator x comma px square is divided by 2m, commutator x comma x square is equal to 0 you are going to get, commutator px comma px square is equal to also 0. So therefore I by m omega into 1 by 2 into m omega square into, so which one we have to write? Px comma x square we have to take. This is the value you are going to write. It is m get cancel, 1 omega get cancel. Therefore what is going to write? It is square root of m omega is divided by 2h cut. This is the entire bracket is there. So x comma px, commutator x comma px into, commutator x comma px into 1 by 2m into px dash is equal to, that is 2px we have to write. It is plus I is divided by I omega is divided by 2 into I omega is divided by 2 into commutator px comma x into, so 2x we have to write. So this 2 1 ja 2 1 ja 2 1 ja 2 1 ja get cancel. Here you have to write it is the square root of m omega is divided by 2h cut into commutator x comma px is equal to I h cut into px is divided by m. So plus I omega. So I omega into commutator px comma x is equal to minus I h cut you have to write it is. So therefore which one we have to bring outside? So we have to bring outside minus I omega you have to take outside. Minus I omega. So you have to take outside minus I omega, you able to take it as a outside. So what is going to happen once you have to see the square root of m omega is divided by 2h cut into, here what is going to happen? Minus I omega is going to out. So we have to take it as a, so what will happen? You have to see x cap you have to write it here. Here x is there. So you able to take it as a x cap you have to take here. Which one you have to consider? X cap. So you able to get it as a x cap you have to write here. So you able to take so x cap I h cut is divided by 2m. So 2m you have to write it is. Here also you have to take, after some time I have to given that x cap. So minus plus minus I. So minus I. So which one we have to write it is p is divided by m omega you are going to get it. So ip is divided by m omega. So minus into minus plus here I h cut you have to take common you able to take. So what is going to happen? So you have to write it I h cut, you have to take, so you have to multiply with I and divided with I. So I square you are going to get it. So therefore you are going to write it as P is divided by m omega, you are going to write it is. So if Ip is divided by m omega, but what is our ultimate goal? Our ultimate goal is dA by dt. So dA by dt is equal to 1 by I h cut into 1 by I h cut into expectation value of commutator A comma H. So commutator A comma H we have to write it is. Here you able to take this entire thing is, so what is the thing you have to write it is, this is A cap you able to take, so therefore, so what you have to write here, so that is 1 by I h cut into I h cut into, so I h cut into A cap minus I omega. So therefore I h cut get cancel, minus I omega A cap you are going to get it. So therefore d A cap is divided by dt is equal to minus I omega A cap. This is your expected answer. Like this we have to do in our competitive examination. What is your answer? So your answer is option B, minus I omega A cap is your answer. This is the equation of motion in quantum mechanics. We are learning this one. Clear? So we already every class I am informing you, we started the CSIR and GATE physics content course we are offering in online coaching. So our app is Quantum Online Academy app we have. So we know that, so we are offering the JL physics and DL physics content we are offering. If you are really interested, you have to take this course. This course will help you to crack the exam. So our course, once you have to download our app, CSIR and GATE physics, JL physics and DL physics courses are there. So not only those courses, we are offering mathematical methods of physics, and this paper is completed. So now classical mechanics also completed. The third one is electromagnetic theory also completed. Now fourth one is running. This is the quantum mechanics paper is running now. So almost half of the core syllabus is completed now under the linear harmonic oscillator. That's why each and every word in the CSIR examination, one question I am giving to you, one question I am solving, I am uploading in our YouTube channel to know our institute, how you have to measure our teaching style also. If you really sync my teaching style, you have to take this course and listen and enjoy the course. Thank you so much.